Hi everyone, this is just a very small lecture to tie off the topic of 2.5, which is Python packages. The first half of this lecture we already talked about importing libraries. This was the idea that there's a whole bunch of modules or libraries built into Python, and sometimes we want to use more than what are built into Python. What we're talking about now is an idea about virtual environments, which is a process of keeping like track of these extra modules and basically managing them. So the best way I can chat through this is that when you install a Python module, and in fact let's just like quickly Google someone, top Python modules. You know, here's some here that I'm just going to use. So if I want to use a Python module on my computer, then what I do is I follow a pretty straightforward process, which is I type in pip3 install requests, right? That's one of these Python libraries. Now it'll go through the installation cycle. It'll be like blah blah blah, I'm installing, oh, I've already installed that one. Let's try PyQt. Oh no, that's probably not what it's called. tkinter. I actually recorded this whole lecture and forgot to click record, so I'm a little bit tired from it. So pip3 install my MoviePy. You can see that this thing is installing now on the computer. Now here's the important thing. If you do a normal pip3 install, then what you're doing is you're installing it to the user account. Now what I mean by the user account is, you know, if this is a shared machine or a CSE machine, you're installing it in the the home directory basically. So the account of whoever's logged in. And I can actually show you this because if I go to home/Hayden, which is the same as tilde, and I go to .local, right, /lib/python8/site packages, and I type in ls, you will see here that this is actually where MoviePy is installed, right there, MoviePy. So that's because pip3 install installs it to my home directory, so that anytime I'm anywhere on my user account, I can use it, right? So if I'm working on project A or project B or project C, or I'm just running a random Python script, or I'm working on the 1531 major project, I can use that module. This is one of 3 different ways to install a Python module. That's the second way. Now the first way is to install it globally. And what installing it globally means is to install it on basically the computer directly. This is how you actually install most programs that you use personally. And to do that, well, it's very different on different machines. If I was using Windows, I would open a administrator PowerShell, which means that I would go to the start menu and I would find the command prompt of some sort, and I would right click on it and I would say like run as administrator. If I'm on Linux, I would use sudo to say I would like admin privileges, and I would do the exact same thing. I would pip3 install something. Maybe I'll install Pendulum or something. So when I do a pip3 install as an admin, right, as opposed to a regular user, I actually install it at the system level. So that means that if my computer has many users using it, they can all use it. That means that if you installed a Python library or module as a system at a system level, then everything that you do, like everyone on a particular, say, VLab machine that you're using would be able to use it. Now, for obvious reasons, you can't install things at a system admin level on VLab, but you know, you can do that locally, right? This is my local terminal. This is not a VLab terminal. So where is this one installed? I actually don't know. I could do a quick Google of it. Where are pip3 global packages installed? And maybe it will tell me, maybe not. Maybe it's too hard to find. I don't know. So they're installed somewhere. It's not going to be there. Python 3.8. Dist packages. There you go. So they're actually installed at the system level. You notice how like this path of the file is not like in my home directory. It's just like in like the root directory of the system, right? It's kind of like in Windows, it's like C slash program files slash whatever. So that's where it's installed globally. Now that's all well and good, but the problem that we face with that is that you can't use this for multiple projects very well. And now here's like, oh god, oopsie. Here's the very basic reason. Well, when you install a dependency, you're not just installing NumPy, right? It's not just, oh, I've installed NumPy and that's the end of it. You're actually installing a particular version of NumPy. And let me just like get a link up here, one sec. And if you remember back from the Python Hello Lab, we asked you to actually install a list of files back in week 1, right? Which was the whole, you had this command that you typed in, which was like pip, actually I can paste it here. This is the last year's command, which is like pip3 install curl such and such and such and such. And that's basically all of the Python modules that we think you need. We get you to install them. Notice here though, how we're actually specifying a version number when we install them. So we're saying install Blinker version 1.4. Now by default, if you try and install something without a version number, pip just figures out what the correct version is. Okay, just like it's like, yep, I'll just figure it out. But here is the problem. The problem is that when you're working on multiple projects, right, sometimes different projects require different versions of a Python module. Okay, some projects might, they might both first start working on Blinker version 1.4, but then what happens is one project down the track wants a new version of Blinker with new features, so they upgrade that to 1.6. Now you might think, well, why doesn't the other project just upgrade to 1.6? Because sometimes the features of 1.6 might be different. Sometimes the interface or API might be different. Sometimes if you try and upgrade a Blinker to 1.6, depending on the other modules you're using, they might not work anymore, right? Like, I don't know if you ever seen, sometimes this happens with like, you know, Google Chrome add-ons or something. Like if you ever try and upgrade Google Chrome, it says like this add-on is no longer compatible, right, with the newer version. So that happens. So it's actually very normal that different projects might actually use the same Python module, but different versions of it. Now this creates a real problem if you're working on two different projects, but you've installed the Python modules on your home directory in such a way that therefore these many Python modules are all trying to work off the same single version. So now we have to talk about a third way to install Python dependencies, which is, when I say dependencies, module libraries, they're all kind of the same thing. Which is, how do I install it at the project level, you know? And it's actually not too bad, and that's kind of what these slides are focused on. Now, to install it at a project level, I use a tool called virtual environments. Now, a virtual environment is a tool that helps keep dependencies required by different projects separate and isolated. It keeps them in virtual environments, right? Like many virtual environments, think about it like a virtual machine. There's a bit more reading you can do on it to read the background and stuff, which we're not really getting into today. And we might ask you a question about this in the exam, but it would be quite light. It's not anything that we really expect you to like massively do. It's more like pretty much just conceptually why they're relevant. Might come up in the exam. Okay, so how do we actually use the virtual environment? It's very simple. So whether you're on your machine or the CSE machine, first thing you do is you go to like your project. Oh, let me go to like my what have we been working on? CS1531 week 2 backend, right? So this is a repo that we've been working on together for a while. And basically inside this repo, oops, let me just move my head a little bit. Inside this repo right now, if I was to do a pip3 install of something, it would just install it at the user level, right? Now that's not particularly good as we've just discussed. So what we're going to do is we're going to use a virtual environment instead. Now whether you're using a CSE machine or you're using a local machine, you do these first two steps Well, you do this first step once on the machine, which is you actually want to pip3 install virtual environment to your user account so that you can use it again and again. Now, I've already installed it. Think of this like installing a program on your computer. That you do once, basically ever. Now you do this next command once per project, right? And what this is doing is this is actually creating a virtual environment on the project itself. And what it's saying is we want to use the Python 3 interpreter to run the module virtual environment and to create a new virtual environment that's stored in a VM folder. So if you have a look here, my project is currently just a README, PyTest, source, and test. And tests. And I can grab this and install it. So now you'll see if I have a look compared to the previous one, right? Here I used to have 4 files. Now I have 5. I have this magical VM folder, and this VM folder is kind of like a bit like a .git folder. It's what the virtual environment uses to track everything, right? So I do that once per project. I've done that for my project now, so it's all there and it's all okay. Now, this is what I do, the third step, every time I start working on my project. And what this is saying is activate the virtual environment. This command is, the only time this changes is if your virtual environment folder is different. So basically inside of every virtual environment, like house folder, is a bin/activate command, and this is VM here because I named it VM. So obviously if I used a different command here, if I used a different folder name, then I would use a different name there. So I would run this one, and you'll notice that my shell changes, my command line. It changes from just looking normal to this VM bracket. Now what that's saying to me is that my command line is now acting on the project and not acting on like my user account specifically. So now what happens, take a look at this, what happens when I install something like NumPy? Bumpy. When I install something like NumPy. So if I install NumPy, it'll go through the same install things, but it's not going to install it to my home directory. It's going to install it to my project folder, and I'll show you what I mean. So I install NumPy. Great, and then when I go inside of VM /lib/python 8/site packages, have a look at this. I have this folder full of packages. Now there's some other things here, of course, but you'll see NumPy. And check this out too when I do a pip3 install. Let's install Pandas, which is another library. You notice now that this doesn't install to my home directory. This installs to the VM directory. Lost my water. Here it is. We'll give this one a sec to install. So now, by ls again, you'll see we also have another line here, which is Pandas. So Pandas has been installed. So that's really like good and helpful, right? And the next step is like, okay, this is good because now I can go and install it on like in one virtual environment. If I would like to go and install it on another virtual environment, I can leave my virtual environment by running deactivate, you know? So you notice that my terminal changed here because that VM changed. And maybe I could go do something in another project. So if I call this like proj2, and then inside of proj2, I could create another virtual environment, right? Like this. Right, so it's been created, and then I could like, same thing here, I could go source this. So this is like, I'm in my second virtual environment, and if I want to get out of it, I can just like deactivate. And then I can go back to my week 2 backend folder, and I can run source activate again like this. That's all well and good. Now, when it comes to git status, notice here how even though I added a new folder, it's not actually like in the git status list, and that's because there's a file floating around in this folder called a .gitignore, and everything inside of a .gitignore Git ignores. That's as simple as it is. And if I open that file, you'll notice that I think that, yeah, so the virtual environment, or maybe this was when Git was added, I don't know. It's actually added this VM folder here. So what it's saying to Git is, please don't track the VM folder. I'm not interested in it. Now that makes sense because the VM folder actually contains all the installs, and you don't want to tie up Python modules into a Git repo, right? Like the point of a Git repo should be to list the modules to install, not have the actual installed modules in the repo. So, the next question is, when I install new modules, how do I make them available for my other team members? Okay, so how do I get my other team members to have them as well? And that's actually very straightforward. So, there's two commands that really matter here, and these are ones you'll be using kind of quite often, which is every time you kind of commit or get a merge request ready for master, ideally maybe every time you commit, you run this command, which is pip3 freeze pipe to requirements.txt. Now let's just look at pip3 freeze first. What pip3 freeze does is it actually takes all of the installed dependencies and it outputs them like that. And you can see that there's 5. And you notice how the format of this file is very similar to my requirements file, and that's because this is like the standard Python way of just listing all the dependencies that are needed. So what I do is I not only pip3 freeze that, but then I say let's output that to requirements.txt. And now I have a file in my repo, a 6th thing called requirements.txt, which just lists out all the dependencies I use. And I actually push this up to the Git repo, right? I actually git add this to share with my team members, right? Now in this case, let's just say, adding requirements, git push origin tay channels or something. And what happens is when my team members, right, let's say I'm like team member 2 here, and I go into, is it week 2 backend? Let's say I'm like, oh, Hayden's made some changes, so I'm going to go and check them out. So I go, team member 2 comes here. I'm going to just reset everything. I'm going to have a look at my branches. I'm going to try and check out Hayden's branch, which was tay/channels. It says there's no tay/channels. So what did I tell you? If you ever want to do that, you can git fetch first, which will get you all the latest stuff from Git. I can check out tay/channels, and now have a look what's here. Now, one important thing to remember is when I said that you only install, like you create a virtual environment once per project, you also have to do that per person. So because person 2 here hasn't set up a virtual environment, they also need to, run these 2 commands. Right, so they create a virtual environment on their machine. Now the next question is, once that virtual environment is created, how do they actually install all those modules without kind of copying and pasting them and running 5 commands? And this is where this really helpful command comes from, which is pip3 install -r and then a file. And what this command does is it takes a text file and it tries to pip3 install all of the modules in that file. So when I run that, it will go and try and actually pip3 install those 5 files, wherever they are. Here, and you can see it doing it. And then if person 2 is to add a new like Python dependency, they would just install it inside the virtual environment, pip3 freeze it, commit that updated requirements.txt, and then push it. And then this is how everyone kind of keeps like a common ledger or a common list of the relevant dependencies. And it also means that like all you have to do when you clone the project again is you don't have to remember those 4 or 5 things to pip3 install. It's all just written there in your repo, right? So if I do a pip3 install of I don't know, Flask, and I'm actually, you know what I forgot to do here? I forgot to activate the goddamn virtual environment. And this is a problem because this install that I did here has just installed all of these to my local machine instead of the project. Now that's not a terrible problem, but also have a look what happens when I do this. Have a look what happens when I run pip3 freeze. I get a huge list because these are all the Python modules that I've ever installed on my CSE machine, right? And this is bad because now if I do a pip3 freeze and output it to requirements.txt, I'm going to make all of my team members have to download all of those modules. So what I forgot to do here was actually activate the virtual environment. So when I run this now, I'm inside the virtual environment. So when I do the install modules, right, like this one here, with this will be quicker. Well, it'll take the same time, I guess. When I pip3 freeze now, it's only going to give me those 5 modules because I'm doing this within that little virtual environment. Taking its time. Great, so when I pip3 freeze now, you'll see there's only 5, which is really useful. Now if I want to install something else, say like let's install Flask, which is a week 4 topic, and then I pip3 freeze, you'll see that now there's like more. Now there's obviously a few more than that because sometimes dependencies install other dependencies, but yeah, there's more than that. So what I would do is after installing that, I would I would update pip3 freeze requirements.txt. Right, so what I've done now is I put my new list of requirements in here, and then I would, as you'd expect, I would git add requirements.txt, I would git commit new requirements. Typically, obviously, I'd put it in some kind of branch or merge request, and then I would, I would git push this t/channels. And just to show you again, the first person working on it, they might git pull, they might get that new file, and then they would pip3 install -r requirements.txt. And then bam, all of the new stuff's installed. So that's how you kind of share work between you. And again, this is great because if I leave this virtual environment, I can go work on another project. And it's a great way to segment and isolate modules from each other when it comes to working on projects. So anyway, that's kind of the high level stuff for dealing with Python dependencies.